Now, learning objective B is going to have us use the law of sines to solve for any missing angles. Let's start with this problem. So on this one, we're looking at triangle XYZ, such that we know the side length of y is 5, z is 3, and the angle of y is 60 degrees. We have to find angle z. Well, first thing, we actually have to draw this. Now, it doesn't necessarily have to be drawn to scale, but let's just do our best here. We'll draw this, and I'm going to call this angle y. So then this will be side y over here across from it. And then we'll call this one here angle z. So the side across from it here would be 30. Therefore, this would be x. Then we also know that angle y is 60 degrees. So the question here, they want us to find angle z. So we need to find z, so we're going to use that angle and its corresponding side in part of our work. The other thing we can use is, looks like we have a pair here with a side y and angle y. So when I set this up this time, since it's the angle that I don't know, I'm actually going to put the sine of the angle on the top of the fraction. So we'll do the sine of z over its side length of 3 is equal to the sine of 60 degrees over the side length of 5. And let's just go ahead and do the sine of 60 in our calculator and divide it by 5. So we'll just keep this as a sine of z over 3. And this right-hand side is going to become 0.173. Now we want to get the sine of z by itself, so just multiply this side by 3 and this side. That'll leave us with the sine of z is equal to 0.52. Now remember, when you want to solve for the variable and it's embedded in the word sine, cosine, or tangent, all you do to find the measure of that angle z is take the sine of -1, or the inverse sine of the 0.52 in this case. When you do that, you're going to get 31.3 degrees. Now, there's something about this problem you have to be very careful of. Whenever they give you a triangle congruency of angle, side, side, in this case, we have an angle, a side, and a side. And if we travel along the triangle, the first thing we come up with is, here's the angle. I'm just going to go backwards. So it goes angle, side, side. So it is the congruency of ASS, which back in geometry you learned this is not a possible congruency. It's a word you shouldn't say, and it also means it's a triangle congruency that can't happen. What the problem is with this, any type of triangle where they give you an angle, side, side, is you have to make sure there's not a second triangle you could have drawn. And here's what I mean. This side right here, the length of 5, has no limitation at this angle and no limitation on this angle. I just drew it like that. Well, why does this length of 5 have to go right here? Could it have been drawn, taken this way and tucked over more? Could I have drawn it this way? So the question here is, could I have left the side length XY right here? So I'm going to draw that. Now this angle has to be 60 degrees, so I'm going to keep it right there. So what I'm going to do this time though is take this side length again and tuck it inward. So if I do that, I would have to draw it right here, so that would be length 5. So then the question is, they want us to find the measure of angle z, which is going to be right here. Well, clearly the measure of angle z looks very different. Now the way to find it is, what you're going to do is actually take 180 degrees minus your current answer. So if you take 180 minus your answer of 31.3 degrees, you're going to get 148.7 degrees. So the question is it possible to even have the second triangle? If you were to put 148 degrees in there, plus you have a 60-degree angle, you've already exceeded your limit for a triangle of 180 degrees. So in this case, the triangle that we drew really is not even possible to happen. But again, whenever you have an angle side-side combination, you must try it out because there could be a second possible triangle, which we will see in this next example. Now I'm going to tell you ahead of time on this one, there is going to be a second triangle that's possible. And again, here's why. We're going to have to sketch it first, and I'll show you it's an angle side-side combo. They're giving us triangle ABC. They gave us one angle and two other sides. So first let's draw this. And if we sketch it out, I'm going to do something like this. I'm going to put A here, B, and C. Now, the measure of angle A is 35 degrees. The next thing it says length AB is 8, so that's here. BC is 6. So this isn't exactly drawn to scale, but that's okay. They want us to find all possible values of angle C, and angle C is sitting right here. Now, before we do the math, I want to show you this. Here's what we could have done differently. This side right here of side length BC, again, there are no limitations telling me what this angle or this angle have to be. So if I imagine it being hinged here and I tuck it inward, it's possible that that side could have come right here instead. If we did that, here's what the triangle would look like over here. A and B are going to be the same. This is still length 8. We're going to have a little bit there, but the leg here is now going to be the 6 units right there. And here we do know it's 35. This here is angle C in the corner, and that's the one they want us to find. So what we're going to do first is the mathematics will always give you the answer to the acute triangle, which is what we call here. If all the angles are less than 90, it's acute. This one here is the obtuse version. Remember, obtuse means it has at least one angle greater than 90 degrees. So let's go ahead and do the math first. And if I come back to the acute triangle, we have to find angle C, so I'm going to match that up with side 8. And I have 6, which matches up with 35. So I need to know the angle, so I'm going to do the sine of the angle first on the top. Sine of C over 8 is going to be equal to the sine of 35 degrees over 6. Now to solve mathematically, I'm just going to multiply both sides by 8 first. And if I do that, this will then become the sine of C equals 0.7647. And I'll go out a few more, 685. Now to find the measure of angle C, remember we're going to do the inverse sine of this particular number up here. And when we do that, what we end up getting is that the measurement is about 50 degrees. So this angle C right down here in the lower is a 50-degree measurement. Now, let's think about where does this other angle come from? How do we get it? I told you it's 180 minus the 50 degrees. Let me show you why, though. Notice here this red line that I drew. Well, this red line is the exact same length. So what just happened is if you look at these two red lines and the bottom of this triangle is an isosceles triangle. Isosceles triangles mean legs are congruent. If the legs are congruent, this angle and this angle is congruent, which means if we found this was 50, this would also have to be 50. But the real question is what's this angle right here? Well, to find this obtuse angle, which is also the same as this one, notice the two angles sit on a straight line. A straight line makes 180 degrees. So to find the red angle here, which is the same as this angle, take 180 minus 50. You're going to get 130 degrees. Now, I think the second triangle has 130 degrees as the answer. Make sure it works. Can this angle be 130 and you have this one at 35? Sure, that's 165 degrees. That gives me enough room to actually make this angle be 15 degrees, and a triangle will actually be able to be made.